then that's going to be what we call a binary molecular compound. So this won't take very long today, maybe 20 minutes at most, and then I'll let you guys work on an extension of this assignment, because a lot of you might be done or really close to done, and then I'll give you an extension on top of this that I'll have you do. So binary molecular compounds. So bi means two, so it's molecular. So if it's molecular, we know what kind of bond forms between the elements. So ionic is ionic bonding, molecular is covalent bonding. And the trouble is with chemistry, and you guys working with chemistry in a general chemistry class, is that we do a lot of things with inorganic and we don't do much with organic. Organic is carbon-based, which is covalent bonds. So a lot of covalent bonding involves carbon. And so when you get to college and you start taking classes that are higher level chemistry classes, they have biochemistry. Well, biology is all carbon bonded. You know, your amino acids, they're all carbon-based. Okay? Carbohydrates, carbon-based. Fats, carbon-based. Okay? I mean, that's the center of it. You go to organic chemistry, all carbon-based. And so it's just like sometimes I wish I could do more organic, and we do a little bit, but we don't do, you won't see very much when it comes to. The only thing that you see is like a lot of the covalent bonding taking place. Now, so we have two nonmetals hooked together. Now, the weird thing about nonmetals, they can hook together a bunch of different ways. They're not like ionic compounds where if you got one that's a +2 and one's a -1, that you have to have two -1s for every +2. And so then you can get your formula. And it only goes together a couple different ways, possibly, especially if you've got one with multiple charges like iron or nickel. So binary molecular compounds, they can go together in, some of them go together in like 5 or 6 different ways. The same two elements. Like, how can that happen? Well, it's just how they share electrons, and they can share electrons in multiple ways. So we'll get into that later, why they do that and why they tend to have that relationship. But what we look at is if we look at the compound and we have a nonmetal out in front other than ammonium, because ammonium is this. Okay, and so ammonium's off your polyatomic ion sheet. So that if that nitrogen's out in front and it's NH4, then you know it's an ionic compound. But if we have a nonmetal out in front and we go to name it, then we've got to use a different system. And the different system that we use, that is used, we use prefixes to describe the subscripts. So up to this point, we have not used prefixes to describe the subscripts. We just haven't done that. And we don't do that in ionic naming. We don't show that. So this is the only time that you see prefixes used. And those prefixes you'll know because they're part of the geometry. Mono. What's next? Di. Tri. This is one sometimes people forget. Tetra. What's that? What's 5? Penta. Hexa. Hepta. Octa. Nona. And deca. So you guys have used that in geometry? Mm-hmm. Okay, and then when you guys look at like how many sided figure you have? What's a 4-sided figure called? Square? Or is it, do they call it a tetra? Do they have something that's tetragon or?
Tetrahedron.
Tetrahedron? What's a tetrahedron?
I don't know. I've just heard it before.
Okay.
Yeah.
So tetra must have something to do with 4. I'm not sure. Well, why don't you guys Google that. What's a tetrahedron? Go ahead and just for my, when you do N2O4, dinitrogen tetroxide. I think the biggest problem is the students don't recognize it, and they would name that nitrogen oxide. Because they would do it just like it would be ionic, like if it's sodium chloride. So the biggest thing is the recognition of the nonmetal out in front. You got two nonmetals hooked together. Okay, so I'll just give you, we'll just give you like a couple more that you can do. Let's just have you do those two. If you notice, you got a nonmetal out in front and a nonmetal behind. So go ahead and name. We can just verbally name them because I don't think we need to write them down. If you want to, you can. So what's P2O5? Diphosphorus pentoxide. So this is diphosphorus pentoxide. And then the next one would be, if you notice, they all have IDE endings, and the first one is the name of the element off the periodic table. So that would be sulfur. Now, that one you have to put the two vowels together, so you'd have to say trioxide. Because troxide, yeah, you need to use that. You need to get the two vowels there together on that one. So it's kind of like it's the A and O that don't go together. Questions you have on that? Yes, ma'am.
So when would you use mono? Like, why isn't it like mono?
Good question. You use it on the second one. So a common one that is a gas that you don't want in your house, and some of you guys have detectors in your house. Carbon monoxide detector.
Okay, so it's only on the second.
It's only on the second that you use mono.
Okay, thank you.
Yep, and that's something students forget. So a lot of times students this label that as carbon oxide, but carbon monoxide shows that second one is one for sure. Okay. So if you have to write the formula, I'm not going to do those, but it would be the same thing. You just use the subscripts for the prefix. Okay. So that's binary molecular compounds naming, and we'll give you some of those to work on. Probably not as many of those to work on as what the other ones, because we don't see those as often. We do see them. Okay? And then the last naming that I don't think any of you know much about, because I did not teach it, and I probably should have taught it, but sometimes you pick and choose what you can get through in a year. And acids are a big part of chemistry. And a big part of our chemistry we're going to do this year deals with acids. Okay, so how would you name an acid? How is that different? So first of all, you have to know what an acid is. Well, an acid is something that gives up hydrogen ions. That's one definition of it. So an acid is something that gives off H+ ions. I wouldn't say produces, but a substance, because that looks like it's a new product, but a substance that contributes H+ ions. Okay. So up to this point, I want you to, well, you have your assignment in front of you. How many on your assignment has an H listed in front of your compound? So if you look at all your names, how many have a name of a compound that starts with hydrogen? And when you look at them, there's not going to be any of them. Okay, so we got this H out in front. It's a nonmetal. So then, like, we have two types of acids. One's called a binary, and then we've got one that's called an oxyacid. It's got oxygen in it. Okay, so those are the two type of acids that we have. So we got one of the two. So binary is just what it says. It's going to be H and a nonmetal. Okay, oxyacid is going to be an H and a polyatomic ion. So if H is put with a polyatomic ion, it's called an oxyacid. If H is put with a nonmetal off the periodic table, or I could say an anion, instead of, the other side's polyatomic ion, this would be an anion. It's called a binary acid. And so charges cancel out on all these. So charges cancel on these, as well on this side. So you're still going to have to balance your charges. The nice thing about balancing charges, the only thing that increases in number is your hydrogen. So you're never going to have, the second element's never going to have a subscript with it, because the first element's always a +1. So it's only the hydrogen where you'd have a subscript with it when you do these, if you have to balance charges out. So that makes it really easy. You don't have to worry about a 2-to-3 ratio or anything like that. So charges cancel. So what's the difference on, so everything's similar, that we're putting them with ions, that they cancel out. But how do we differentiate between a binary and naming it and an oxyacid naming it? Okay, so this one starts with the prefix hydro. So when we name this one, it starts with hydro. I'm not going to put prefix hydro, but I'm just going to say it starts with hydro. This side doesn't start with hydro. I'm not going to put that down. I'm not going to put down what it doesn't do. I'm going to put what it does do here later. So binaries have H out in front. We recognize it. If we put the formula together from the name, the charges cancel. Acids start with hydro. So what do they end in? Well, these are going to end in ic acid. IC acid. So binary, hydrogen out in front, charges cancel. If we name them, they start with hydro and end in ic acid. Alright, so on the right side, what do these start with? Okay, they start with the name of the polyatomic ion. So these will start not with hydro, because we don't need to differentiate between the two. These are going to start with the polyatomic ion name. Like, look up NO3. Like if we have H with NO3, look up NO3. What does NO3 start with? What's the beginning of NO3's name? Night. Okay, what's the beginning of NO2? Night. Oh, wait a second. That's not going to work, because if we have to differentiate between NO2 and NO3, how are we going to do it? So what's the ending of NO3? 8. Okay. What's the ending of NO2? 8. Okay. Let's pick out some other ones that have endings that are 8. What are some other things that have endings of 8? Sulfate? Cyanate? Acetate? Which one did you say? Perchlorate. Okay, there's a lot of 8s. Okay, how about ites? Are there a fair number of ites?
Chloride,
Chloride,
bromide.
bromide. Okay, so if you look down the list, there's a lot of endings of eights and ites. And so it's like, okay, they can have the same beginning, but they can't. We're going to have to find some way to express ite and ate differently. So what these are going to end in are two possible endings. They're going to end in IC if ATE ending. Okay, so if it's an ATE ending, it's going to end in an IC. And I'm running out of room, but if it I should have did it the other way, but that's okay. So it will end in OUS if it's an ITE ending. Okay, so we're going to put this together and do some examples, okay? So the right side, oxyacids, H plus ion in front. We recognize it. Charges cancel when we put them together. That's easy. The name of the oxyacid is going to start with whatever the polyatomic ion's name starts with. But the ending is going to change based upon if it has an ATE ending or an ITE ending. If it ends in 8, the polyatomic ion, then the name is going to be ic. If it ends in ITE, the ending is going to be us. Okay? And so the way I remember this is I remember the difference is I ate it and it was icky. Or I ate something and that was icky. Alright? And then I don't know the other one. If I got that one, another one's pretty, it's the other example. Alright, so let's just take a look and differentiate some of these out and see which side we'll use and then how we'll name them, how they'll be named. Okay, so let's divide these out. When we take a look at these, which are binary? So 1 through 6, what numbers are binary? Up here.
HCl.
Okay, HCl is binary. You guys don't have to write this in. What else? HBr, binary. Any others? Think that's it, right? I'm not going to list what the other ones are because they're going to be with the polyatomic ion. So if I was naming this and it's binary, what do we know it starts with? Hydrochloric acid. Hydrochloric acid. So 4 will also be hydro, right? But it's going to be what? Hydrobromic acid. Does that make sense? So anything that's binary, you're going to go put hydro in front of it. You're going to go to the root word of the name of the element, bromine. Change the IDE to ic, acid. Okay? Now let's check the other ones. The other ones we have to start with what?
The
Polyatomic. So this is 9. So NO2 has what ending? Ite. So that becomes us. I think I remember the other one. It's not I, but us. There's no I in team, right? So it's not I, but us. Right? Nitrite. And I ate that and it was icky. All right, so nitrous acid. All these, the only thing I didn't include on that last one, yeah, they all have endings of acid. So go ahead and do 3, 5, and 6 and see if you can get those names right with the one example I gave you. So 8's become ick, and I's become us.
Since for like the oxalates and things like yours, how it's H2, was that just telling you that it's like on the charge of -2 on the polyatomic ion sheet, or like what does that do?
Go ahead and say that again.
How there's a 2, like on the 1 through 4, it's just 1H. But on 5 and 6, it's H2, and then the polyatomic ion.
Yeah, your spellings and charges on those, I think, aren't you? So, on these bottom two, you mean?
Yeah, like that doesn't change anything with the name.
No, it does not. No, because if I write the name, I can get the formula back out. Because if I have the name and it says oxalic acid and I have to write the formula, the IC I know to look up the oxalate. So I'm going to go C2O4. And then I notice that's a -2. And then I look up the hydrogen, and hydrogen's a +1. So that's H2. Yeah. Yeah. If I can write the original substance out from the name, and then if we know the endings X or 8s, and we've looked up the 8 part of the oxalate, realize the charge of it, then we can go ahead and balance it out. And that's why we have those that's how we can do those. All right? All right, so those are the answers for those. I'm going to go ahead and add to the assignment. It's not going to be a big additional number that you have to do of what I gave you yesterday. But I'm going to give you some that include some combinations of nonmetals and some acids.
Are we going to be turning these in?
Yes, I want to look at them. I'm pretty sure you guys are doing really well at them, so